Hey guys, welcome to today's video. In this video, we're going to be exploring the Terraform's resource and data block. For those of you who are just watching this video on this channel or for this series for the first time, you may want to watch the previous videos or the previous topics such as providers, Terraform architecture, backends, remote backends covered in this series or in this playlist. I'll have a link to the playlist at the end of the video, so feel free to go through them. Now, in this video, we're going to be exclusively covering resources and data blocks. So let's go ahead and start with resource. So first of all, what does a resource block actually represent, right? A resource block actually represents the underlying infrastructure, the physical infrastructure object that you want to, work with or create using Terraform. So I'm talking about S3. Think about like S3 buckets, IAM roles, EKS clusters. Then we've got database services like Redshift or even RDS instances or even EC2 instances like compute resource. Now they're all basically a type of resource that exists within AWS provider or within the AWS cloud space. Now Google has got their own resource types and Azure has got their own resource types. The best way to get information about them is to basically go into Google and go into just Google AWS provider Terraform, for example, and then once you go into the provider's documentation, you'll see on the left hand side there's going to be a glossary for all the resources that are available to be created through Terraform using the AWS provider. So let's say if I go into let's say CloudWatch. So I'd go into CloudWatch dashboard. There's be examples about how to use this resource block for CloudWatch, and then there will be documentation around the arguments that are required and any further information about them. So you're going to find it for any resource that you're trying to work with Terraform. The resources have two arguments that you need to pass in, or two reference blocks, or sorry, reference parameters. The first one is always the type of the resource. So there is always, this has to be from the documentation of the cloud provider that you're looking at. So in this example, it will be everything that you can see on the left hand side basically in the glossary. Each of them represents a particular inside each of them there are like particular types of resources, and these are all basically the types. And in this particular example, I'm working with the type of AWS IAM role and IAM role policy attachment. They're two different resources. And this basically instructs Terraform to use the API for this particular resource behind the hood and actually manage the creation or lifecycle of this particular resource in the actual cloud provider, the actual real physical object. The second argument implies the local name for that resource type. So and this combination of the local name and the type needs to be unique in Terraform, right? So you cannot do something like this, right? For the same type of resource, you've got the same name. This is not going to work. There's going to be an immediate failure Terraform. So if I do Terraform plan, it's going to say duplicate resource. So if you need to have a multiple block of the same resource type, then make sure you give it a different name or use a for loop, which we'll cover later on in this series. So now Terraform will be happy. So if I run a Terraform plan, the Terraform plan may take a few extra additional seconds to run depending on the API call. But yeah, now Terraform doesn't complain, as you can see, but we'll go ahead and get rid of this. So now in this resource blocks, you can perform 4 different types of operations, and we'll have a look at them with example shortly. But just to name them, they are creation, deletion, update, and lastly destroy and recreate. So the first operation that we're going to be looking at now is going to be a create operation. What it does is that it just basically adds your resources. For example, I haven't actually run this configuration through and applied it in the real world yet, or in my AWS account yet. So that's why Terraform is trying to actually create them. And I'm going to go in and just do Terraform apply, and I'll just flag it as auto approve, just because I've already seen the plan and I know it's very minimal and there's nothing really changed, so I'm happy to auto approve it. So you can see Terraform's basically doing the same thing, and I just added it. Great. Now if I go back into the code, and let's say I want to now comment this bit out, this is going to now signal Terraform to destroy this particular resource type of IAM role policy attachment, because from the configuration it has been removed, and that's what Terraform is always going to try to do, right? It's going to look at the configuration and look at the state or what's in the state and try to make sure they're always aligned. So the operation is destroying here, and it's trying to destroy as expected, but we are actually going to put it back on because I don't really want to destroy it. Now let's look at updates. Now what's update? So update in this example, for example, if I want to add a tag to this particular resource environment, let's say dev, in just a map, put it in key value pair, and if I now go in, we don't really need to go in there. Let's clear it. Plan. Now we're going to see that Terraform is not going to try to add anything or even destroy anything, but it's going to try to change, and there you go. And the operation here is update in place. Now this is not going to work for all the arguments, right? So let's go ahead and actually get rid of this, but we're now going to go and update this to, let's say, get rid of this new. So all we did is ever so slightly change the name, but let's see what Terraform comes up with. So running a Terraform plan now is going to actually trigger our replacement. Now this is the fourth operation that I mentioned, which is destroy and then create replacement. And you can see the keyword here, which is forces replacement. Now why is this forcing a replacement, even though all I did was just literally change the name? The reason it's doing that, it goes back to the documentation. So let's search for IAM role here, and now I've got AWS IAM role, and let's search for the argument name, which is this. And if you look here, it says it's an optional field, but if you have specified it and if you have changed it, then it forces a new resource. That's what the forces new resource means. It basically means that if you have already applied your configuration with the name, and then you come back to the configuration and change this or update it, it's always going to force a new resource. And this is why Terraform is trying to basically telling you that it forces replacement. And this is why Terraform is trying to destroy it first and then recreate it. And this is also the same for any field that you see in the documentation that has required next to it. Any field that has been marked as required is also going to always, if you do any update to it, it's always going to do the operation of destroy and then create a replacement. So remember this particular point when you're working with resources in Terraform. Now, interestingly, you'll see that even though the change was done on this particular resource, AWS IAM role, Terraform is actually trying to also replace the resource IAM role policy attachment, which is, we haven't even touched this one. Now, the reason Terraform is doing that is because implicit dependency. Now, what is implicit dependency? Implicit dependency is basically Terraform automatically figuring out that this particular resource type is actually dependent on the AWS IAM role resource type. And it's doing that because when Terraform APIs are being called, the way Terraform is designed, the APIs calling the API that is being used to attach a policy is dependent on this particular role, right? So if you think about it, the resource has already been created with a particular role that was defined for it. Now, since these two are linked, right, I've basically specified the path of this resource type and the name of it, and then basically accessing the name argument for this resource type. So if I change anything in here, it's also going to be changing for this resource type, right? And that creates an implicit dependency in Terraform. So we don't explicitly have to say anything, but it does change it. Because a policy at the end of the AWS has to be attached to a role. So it needs a role for it. And if anything is happening with that role, the policy is also going to be invalid, right? If the role is having a name change and Terraform is recreating it, then any policy attached previously to that role is also not going to be there anymore. And that's what Terraform is doing. Now you can also make dependency explicit. The best way in Terraform is really to make everything implicit. Now there are certain cases where you have to be explicit, and that happens, for example, you've got a container registry where you're pushing your Docker images, and you've got a Kubernetes cluster, right? So you can create these two types of resources independently, in parallel. However, you can't actually pull any images down into your Kubernetes cluster. Here I'm talking about a private corporate environment example, right? You're not going to be, your application code that your product development teams develop are going to be stored in a private ECR, which is the container registry in AWS. So you need a container registry to be there to store these images that you're going to be referencing in a cluster first, right? So there is no direct dependency between them, but you can explicitly make them dependent upon each other, because as a best practice, if your container registry doesn't exist, then the cluster can be there, but it's kind of going to be useless, right? Because you can't really deploy any apps because none of the images are going to be there. Just an example. But in those cases, you could always use argument called depends on, and in depends on, you just basically just give the unique identifier of that resource. So in this case, this is going to be just example role. In this particular example, it doesn't really make any difference because they're already implicitly dependent upon each other. But if you wanted to make any two resources explicitly dependent upon each other, you can do so like this. And this is also actually a list, so you can put multiple dependencies inside one dependency block, right? So one resource could be dependent on multiple different resources. And yeah. So going ahead and looking into, let's say, the data block a bit, right? So what is a data block? Now, data block is representing also an infrastructure object, but you cannot create this type of infrastructure objects through Terraform. You can read them, however, and read all the attributes of it. So if I go and clear this and run a Terraform plan, and I actually uncomment this bit now, I'm not going to be going into output or even locals actually in this session, but in the next video I'll cover them. But for now, think of output as just a way to basically print information about these data or resource blocks in the console, right? So we can easily see it. So if I run Terraform plan now, you will see that there's going to be something printed out called account ID in the console, which is this. Now, Terraform is getting this information. It's basically my AWS account ID. And Terraform is basically pulling it out through this data source called AWS caller identity. Now, again, similar to resources, these data blocks also exist in the provider documentation. So if I go ahead and actually search for the caller identity, so you see it's data sources. Again, same principle in here. You go through, you've got an example for the usage of it, and you have some attribute reference, which gives you a bit more information about the data source. But these have got, for example, this particular data source has got these particular attributes that I can read, and that's the key difference between data blocks and resources. So resources, you can perform the operations such as create, update, delete on them. Whereas in data blocks, you can only perform the read operation. You cannot perform create, update, or delete on any data blocks in Terraform. You can only do read, and that's the key difference. But in terms of dependencies, again, data blocks work in a very similar manner to resources. They usually have implicit dependencies. But if you don't have implicit dependencies, if you don't want implicit dependencies, you can also do explicit dependencies in a similar manner, right? You can do like depends on, for example, and you can do, again, just put the unique identifier of any resource or another data block you could create, and you would put that as a dependency on here. And that's about it, really. Data and resources are very similar, basically, in order for like the definition and how they work. The key difference is that data sources can only be read, whereas resources can be created, updated, and deleted. And yeah, that's it. If anybody has any question, then please feel free to drop it as a comment in the video's comment section, and I shall see you in the next session. Thank you. Bye.